In this video, I want to talk to you about how you actually go about calculating differentials. So the first thing to note is a differential is just dy, which is equal to f prime of x dx. So we represent the differential by dy. And we can also think of this as dy is equal to, using the Leibniz notation, dy dx times dx. Now, we spent a lot of time making sure that we understood that dy dx is actually the symbols for derivative. But the beautiful thing about Leibniz notation is that if we were to think about this as a fraction, then we see that even though we really can't do this, dy is equal to dy over dx, and then the dx could kind of cancel. So this is an excellent way for you to remember how the organization goes so that you'll be able to put it together and actually do problems. So how do we calculate the differential? Well, the first thing, dy, we remember that we've got that dy is equal to the derivative times dx. So the first thing we'll have to do in all the problems is calculate the derivative of your function. Then the second and final step would be just to multiply that derivative by dx. So let's look at an example. So in example 1, we're asked to find the differential dy if y is equal to sine x. So our first step will be to take the derivative of y equals sine x. So we get that dy dx is equal to cosine x. And then our second step says take the dy is equal to the derivative dy dx times dx. So we just take that derivative we found in step 1 and multiply by dx. And when we do that, we get that dy is equal to cosine x dx. And there's absolutely nothing more to it. Let's look at a second example. In example 2, we're asked to find the differential dy if f of x is equal to the natural log of x squared plus 1. Our steps are going to be exactly the same. First, we're going to need to find the derivative of the function. I've started that there. So f prime of x, our first step is going to be, because we have a composite function, would be to take the derivative of the inside. Derivative of x squared plus 1 is 2x. Then we'll multiply that by the derivative of natural log of u. So that's always 1 over whatever was inside. So that's 1 over x squared plus 1. We can simplify that. Multiply the 2x to the 1. So we get 2x over x squared plus 1. And now we're ready for step 2. We're going to find dy, our differential, by multiplying the derivative by dx. So we're going to simply take that 2x over x squared plus 1 and multiply by dx, and we're finished. So when we're calculating differentials, we just want to remember that if we can find the derivative of a function, we can find the differential, because the differential is simply the derivative multiplied by dx. And I should just add that dy and dx are generic. That's for a y being the dependent variable and x being the independent variable. If those letters were to change, you would just interchange your symbols as well.